So we'll start the first question of paper 1. So very good question. So the work done is asked. There are 2 steps, initial, then intermediate and final step. This is step 1 and this is step 2. So they have mentioned there are 0.5 mole, number of moles is 0.5 and the temperature is given as 600 and the initial pressure is given as 2 bar. So the pressure 2 bar, the final pressure is P, from final pressure P to, the initial pressure of P to final pressure 8 bar. And the reaction takes place at constant temperature and also the reaction takes place at constant pressure. So as a result, the work done in the first step will be minus P external into V final minus V initial. So that will be external pressure is P, V final is nRT divided by P final pressure, that is P, minus VI is nRT divided by initial pressure, that is 2. Clear? So this can be simplified as, you can write it as nRT can be taken out. So this will be P by 2 minus 1. So the next step, work done from intermediate step to final step. So the second step is, same formula could be used. Now the P external minus V final minus VI. P external is equal to 8 bar now. So V final is nRT divided by 8 minus V initial will be nRT divided by the initial pressure of the intermediate step, that is 2. So this if you simplify, this is equal to P. So this if you simplify nRT, if you take it out, nRT is equal to, this will be 8 by P minus 1. Now the total work done will be, the work done in the first step, work done in the second step. So the work done in the first step will be nRT into P by 2 minus 1. We will add it together, plus 8 by P minus 2 on adding. So they have asked the minimum work done. For that, the condition should be P by 2 should be equal to 8 by P, that is P is equal to 4. So minimum work done will be equal to nRT into 2 plus 2 minus 2, that is 2 nRT. So 2 into the 0.5 moles R, temperature is 600. This can be 600 R. The answer is option B. Very simple but very beautiful question from thermodynamics.
Alright, and then they have also mentioned that at time T equals 0, the concentration of the reactant is R0, and of course will not have any products. Fine, and then at time T they have said that the concentration of reactant is some R and product is P. Okay, and then let us have a look at the subsequent information that is given to us. And they have said that the rate constant of backward reaction is equal to 4 times the rate constant of forward reaction. Let me put that on the board. Kb is equal to 4 times Kf. And then you also know that Kc, which is your equilibrium constant, that is equal to rate constant of forward reaction by rate constant of backward reaction. All right. Now, sorry, it's the other way around. Rate constant of backward reaction by rate constant of forward reaction. Now, I know that Kb is equal to Kc is equal to Kb Kf divided by Kb, and then this is Kf as it is. I have changed it, I'm sorry. And then I know that Kb is equal to 4 times Kf. Alright. And now what happens is F and F gets cancelled out. Therefore, Kc is equal to 1 by 4. Okay. So equilibrium constant is equal to 1 by 4. Now let's get back to this one here. I know that equilibrium constant is equal to concentration of products by concentration of reactants. And then I also know the Kc value. That is what? That is 1 by 4. That's equal to concentration of products by concentration of reactants. Then in the next step, I understand that if I simplify this further, concentration of reactants is equal to 4 times the concentration of products. So from here we understand further that concentration of reactants is going to be greater when compared to that of products. And hence the conclusion we can draw is this. Anyway, the initial concentration, the initial molar concentration of the reactant is going to be R0, and that is constant. So therefore, molar concentration of R by R0 is of course going to be greater when compared to molar concentration of product by the initial concentration. And hence, to conclude this, when we draw a graph of molar concentration versus time, the molar concentration of reactants goes on decreasing till a particular point, and then it remains constant, and then the molar concentration of products goes on increasing, and then at equilibrium it remains constant. And since we have understood that the concentration of reactants are more dominant when compared to products, the graph follows this particular sequence. And if you look at these options here, it maps to option C. Now let's move ahead to the next question, which is
I'm going to discuss advanced paper 1, section 1, question 3. The question is, sir, can you post the question? The correct order of dipole moments of the given species is, see, they have given 4 molecules and they are asking us what is the correct order of their dipole moments. The molecules are like this. We have BF3. First is you have BF3, then you have NH4 plus, NH4 plus, NH3 and NF3. Okay, so you have 4 molecules. Now how to analyze this question? Very simple. Let's write the structure of this. When I consider BF3, BF3 has a trigonal planar structure. This is a trigonal planar structure. When you mark the dipole moments, fluorine is more electronegative, therefore this is how the dipole moment will be. And the resultant dipole moment will be like this. Therefore, the dipole moment of this will be exactly cancelled with these 2 bonds. Therefore, mu is equal to 0 for this molecule. Then, when I consider NH4, NH4 has a tetrahedral structure. Okay, so you have a lone pair of electron and you have a coordinate bond there. So therefore, the structure is like this. Now here also the dipole moment of this will be exactly cancelled with this. Okay, the direction will be opposite here. So as a result, mu is equal to 0. Okay, therefore the conclusion here is these 2 molecules are having 0 dipole moment. Therefore, among the 4 options, you can easily say that BF3 is equal to NH4 plus. Okay, then we can analyze the rest too. So we have NH3 and NF3. Okay, so even in NCERT also this question is there in the bracket. So you have NH3 and NF3, right? NH3 and NF3. Both of them have got similar geometry. When I consider NF3, NF3 has a pyramidal shape, right? So you have H, H and H. Now you have nitrogen as the central atom and you have one lone pair here, F, F and F. So if you mark the dipole moments, you know that among nitrogen and hydrogen, nitrogen will be more electronegative, therefore the dipole moment will be like this. So therefore all the dipole moments are getting added up. Even this dipole resultant dipole moment will be like this. Therefore this case dipole moment will not be equal to 0. Now we need to compare these two. Okay. So the dipole moment of this will be in this direction, lone pair. If I look at nitrogen and fluorine, fluorine will be more electronegative. So that's why we are going to get it like this. Therefore, the resultant dipole moment will be on the opposite direction. But they are not equal because the dipole moment caused by this lone pair of electron will be different from the dipole moment caused by this NF bond. As a result, some dipole moment will be getting cancelled up. Therefore, here dipole moment will not be equal to 0. But comparing these two values, definitely NH3 dipole moment will be greater. As a result, we can say that BF3 is equal to NH4 plus, then which is less than NF3. Okay, which is less than NH3. Therefore, among all of them, so NH3 is having highest dipole moment. Therefore, according to the option, sir, can you show the option? According to the option, it is option A, where BF3 is equal to NH4 plus, then it will be NF3, then it is NH3. Therefore, it is option A. Option A. Thank you.
So here in the first reaction we have carboxylic acid functional group and an ester functional group. And the given compound is chiral. Okay, so this compound not labeled, reduced with lithium borohydride LiBa H4 and followed by acid hydrolysis. This reducing agent will reduce the ester into alcohol functional group. Into alcohol functional group, while carboxylic acid functional group remains in the same form. This is resulting structure of P. And then the same compound when reduced with borane BH3 followed by acid hydrolysis, it will reduce carboxylic acid functional group, but the ester functional group remains undisturbed. The first step. Second step, acid hydrolysis will hydrolyze the ester into carboxylic acid. Okay, into carboxylic acid. That's the structure Q. So in reference to this given chiral center methyl group, the resulting OH group and the branch, substituent branch holding the OH group in the structure P is on the same side. In comparison to that, the isomer Q, the stereoisomer Q for P has the same OH group with the branch. In reference to the methyl group, it is on the opposite side of the ring. So they will be like comparable to geometric isomers, cis-trans isomers. But you can't name them as cis-trans, you can use EZ here, but they are geometric isomers. So I repeat, the branch holding the functional group OH and the methyl group here are projected on the same side of ring, while on the other side you have methyl group and the OH group functioning branch, it is having the orientations on the opposite side. They are diastereomers. P and Q are diastereomers. Next, one more reaction. In the same way, the second reaction can also be dealt with. Lithium borohydride reduces ester to alcohol, which is obtained after acid hydrolysis, while the carboxylic acid functional group remains undisturbed. So we'll be getting alcohol and carboxylic acid. On the other side, the borane reduces carboxylic acid, followed by acid hydrolysis. The ester gets hydrolyzed to carboxylic acid. In the first step, the carboxylic acid becomes alcohol. In the second step, the ester functional group undergoes hydrolysis to form carboxylic acid. Now, as before, this alphabet R and alphabet S, in reference to the methyl group projected above the plane of the board or towards the observer, the branch holding the OH group is also projected in the same orientation. While the stereoisomer S for R, the OH holding branch is projected below the plane of board and methyl is above the plane of board. So these two are geometric isomers, hence diastereomers. Even R and S are diastereomers. Okay, so the correct option here is option C, telling both R, PQ are diastereomers as well as R and S are diastereomers. Okay.